Okay, class. Now we're going to go to 11.6. We're just doing 11.6 today. We're taking it a little slow here. There's been a lot of questions on this stuff. We're going to do events involving not and or, and a little bit with odds. When you look at casinos and sports and whatnot, they talk a lot about odds. What are the odds of winning? The odds of this particular team winning, and so on and so forth. We're going to talk a little bit about odds. So all this stuff is just pretty basic versions of this stuff. Does not apply. It's easy. Okay. So first we're going to talk about the complement rules of probability. Okay, so first, if I have a probability of an event E, and then the probability of an event that E doesn't happen, those two should add up to 1. This is just a fundamental theorem. Okay, so that means that basically implies that the probability of E is 1 minus the probability of not E if I just subtract this over to the other side. And that also means that the probability that E doesn't happen is 1 minus the probability that E does happen. Okay? That's an important theorem. This whole idea right here is that the probability of something happening and it not happening are add up to 1. Okay, so let's do a problem here to illustrate this. All right, so if you're dealt 1 card from a standard 52 deck, find the probability you are not dealt a diamond. Okay, so the probability that you are dealt a diamond is, let's look at how many diamonds there are in the deck. There are 13 diamonds in the deck. I'm going to divide that by the total number of cards. That's 1 and 4. Okay, so the probability of not getting a diamond should be 1 minus the probability of getting a diamond, which would be 1 minus 1/4, which is 3/4. So that's the probability of not getting a diamond. All right. Okay, now we're going to talk about mutually exclusive events. Okay. If it is impossible for events A and B to occur simultaneously, the events are said to be mutually exclusive. That means they don't affect one another. They cannot both happen at the same time. The obvious of mutually exclusive events would be I win the game and I lose the game. Those are mutually exclusive events. Okay? I am over 6 foot tall. I am under 6 foot tall. Those are mutually exclusive events. If A and B are mutually exclusive events, then the probability of A or B happening is the probability of A plus the probability of B happening. Okay, if they're mutually exclusive events, meaning they can't both happen at the same time, or they're unrelated events. Okay, so if I want to find the probability of A or B happening, that is the probability of A plus the probability of B. Okay, A or B means the same thing as A unioned with B. Okay, this is just set notation, all right? That little union means or. Okay, so we'll get into that a little bit more later. Let's do an example. Okay, so here's one. If you roll a single 6-sided dice, what's the probability of getting either a 4 or a 5? Notice it's key here, the word or, right there, okay? Or. So these are mutually exclusive events. You can't get both a 4 and a 5 at the same time. You either get a 4 or a 5. So these are mutually exclusive events. So the probability of a 4 or 5, should be the probability of a 4 plus the probability of a 5. Well, probability of getting a 4 is a 1 in 6 chance. The probability of getting a 5 is a 1 in 6 chance. So that's 2/6, which is 1/3. So you have a 1 in 3 chance of getting a 4 or a 5. That makes sense because 4 or 5, there's two different options and there's 6 total options. So it should be 1/3. That makes sense. 2 out of 6. Okay. Okay, let's say they're not mutually exclusive events. Then what that means, guys, is that they could happen at the same time. They could happen at the same time. Like you could get a king and a diamond. You could draw a card that is both a king and a diamond at the same time. All right? using set notation. So P of A or B when they are not mutually exclusive events, okay, is P of getting an A or a B is you take the probability of A, the probability of B, minus the probability of A and B. Okay, let's look at an example of this. In a group of 50 students, 23 take math, 11 take psychology, and 7 take both math and psychology. If one student is selected at random, find the probability student takes math or psychology. These are not mutually exclusive. The reason they're not mutually exclusive is because there's some students that take both math and psychology. Okay, so I want to find the probability that this would happen. So there's 50 students. So let's find, so the probability of math or psych, I can't write today, sorry, should be the probability of math plus the probability of psych minus the probability of math and psych. Well, the probability of math is 23 students take math out of the total 50, plus the probability of psychology, which is 11 students take that out of 50, minus the ones that take both math and psychology, which would be 7 out of 50. Okay, so now how do we deal with odds? Okay, at this point I'm going to give you your Easter egg. Okay, your Easter egg is 4, 1, 1, 1, 2, 3. That's 4, 1, 1, 1, 2, 3. Okay, now we're going to look at odds. Odds is actually really pretty easy. The odds in favor of E are found by taking the probability that E will occur and dividing the probability that E will not occur. This is pretty simple. The odds against F are taking the probability that E will not occur divided by the probability that E will occur. So this is the definition of odds in favor of an event and odds against an event. So let's take a look at an example. The winner of a raffle will receive a 2-year scholarship to the college visitor choice. If 1,000 raffle tickets were sold and you purchase 5 tickets, what are the odds against winning your scholarship? All right, well, the probability against winning your scholarship, so odds against would be, we're going to use this one here, the probability, whoops, I shouldn't have put parentheses there, my bad, probability of not E over probability of E. Well, the probability of not E is you bought 5 tickets, so the probability you're not, and there's 1,000 raffle tickets, so the probability you're not going to win is 995 out of 1,000, right? Because the probability you are going to win is 5 out of 1,000, and 1 minus that would be the probability that you're not going to win. Okay, then I divide that all over the probability that you will win, which is you bought 5 tickets, you have a 5 in 1,000 chance. Okay, this ends up just being 995 over 5. Okay, and then when I reduce that as a fraction in my calculator, if I hit 995 divided by 5, and then I hit math frac, change it to a fraction, the odds against me winning are 199 to 1, or it's a fraction, 199 over 1. We usually write odds as a fraction, okay? But since it's over 1, we can sometimes write it as a ratio like this with the colon. Sometimes it's written that way when you look at odds at a casino and whatnot. The reason that is true is because this is, if the way you do this fraction divided by fraction is you do 995 over, well, I'm not a room there, hang on. The way you do this is up here, you do 995 over 1,000, and you flip the bottom one, copy dot flip. So that'd be 1,000 over 5, and then these cancel. So you get 995 over 5, which is 199. So the odds against you are 199 to 1. So you're probably going to lose because you only bought 5 raffle tickets. So that is how odds work. Okay, this is some problems from the book here. Exercise 27 to 30, you're dealt one card from a 52 card deck. Find the probability you're dealt, and we're going to 28. So a 5 or a black card. Okay, these are not mutually exclusive. The reason they're not mutually exclusive is because you can draw a black 5. So you can actually draw a black and a 5. You can draw a black 5. So this is not mutually exclusive. Mutually exclusive would mean it can't be both 5 and black at the same time. So the probability that I draw a 5 or black card would be the probability of a 5 plus the probability of a black minus the probability of a 5 and a black. How many black 5s are there, I guess, is the question. So the probability of drawing a 5. Well, the probability of drawing a 5, there are 4 5s in the deck out of 52. Plus the probability of drawing a black, there are 26 black cards out of 52. Minus how many 5 and blacks are there? How many black 5 cards are there? There are 2 black 5s, a spade and a club. So that'd be 2 out of 52. So they all have the same denominator right here. Okay, so I can just add the numerators. That'd be 30 minus 2 is 28 out of 52, which is divided by 4 is 7 over 13. You have a 7 out of 13 chance of drawing a 5 or a black card. Okay, look at number 30. Okay, I'm going to erase some of this. Give me a second here. So if we look at number 30, this is, I want to say, find the probability that a card greater than 2 and less than 7. Or a diamond. Okay, so it has to be between 2 and 7 or a diamond. These are not mutually exclusive because there's a lot of cards greater than 2 and less than 7 that are diamonds. So it can be both between 2 and 7 and a diamond. So what are all those cards? So the probability of a card, I'm going to say between 2 and 7 or diamond, should be, using the formula, that's the probability of a card between 2 and 7 plus the probability of a diamond minus the probability of a card being between 2 and 7 and a diamond. So we got to figure out how many cards are there between 2 and 7 that are diamonds. Well, let's look at this. The probability of cards between 2 and 7. Well, that'd be 3, 4, 5, and 6. So let's analyze this here. 3, 4, 5, and 6. So that's 4 cards. 4 number cards. Cards that have a 3, 4, 5, and 6 on them. And each of those numbers has 4 cards. There's 4 3s. There's 4 4s. There's 4 5s. And there's 4 6s. Okay, so there's 16 total between 2 and 7. So that'd be 16 out of 52. Plus, probability of a diamond, 1/4 of the deck is diamonds. 13 out of 52. So I'll just leave that as 13 out of 52. My bad. I'm reducing the fraction. Now, between 2 and 7, how many diamonds are there? Well, there's a 3 of diamonds, a 4 of diamonds, a 5 of diamonds, and a 6 of diamonds. So that would be minus 4 cards out of 52, because there's a 3, 4, 5, and 6 of diamonds. So it has to be between 2 and 7 and a diamond. There's only 4 such cards. So 16, adding these numerators up, that'd be 29 minus 4 is 25 out of 52 chance. Okay, so that should get you ready for the homework. We've done enough examples. You should be able to swing that. We will chat later. If you have questions, set up a Zoom meeting with me or shoot me an email.